Good morning, everybody. Can you hear me? Can you hear me? Thank you. Oh, good morning, everybody. It's 8 o'clock. We'll get started here. All right, so let me start out by saying in the syllabus, I've now got a requirement that people show themselves on video if they're going to attend the Zoom meetings. In the past, people haven't, and I've been doubtful of their level of engagement. So at least I think if you're on video, then you're a little more accountable for what you're doing in the class. So that's where I'm at with that. So every now and then I'll be checking to make sure that people do have the video. If you can't have your video on for whatever reason, hopefully a good temporary reason, you'll let me know via email before the meeting, and we will see what we can be done about fixing the problem. All right. Let's go back to where I was here. And I'll share the screen here. We'll get started. Okay. All right. I've heard from a couple of people, but let's see. So you'll need to, anybody here who is on should be connecting to their video, as I've heard from one person who can't, but the others here should be. If you don't have your video enabled, you should be enabling it now, please. Okay, thank you. Okay. If you took 2045 with me last semester, then you know the setup that I'm going to show you here for the course is going to be pretty familiar to you. If you didn't, you'll get familiar with it pretty quickly. Okay, so over here in the syllabus, you all can see my screen, I hope. Yeah, well, I'm sharing, so you should be able to see it. You'll see a couple of phone numbers here. That's my office phone number, which I don't think you should be using because I'm not there. But you should use my cell phone number. And I haven't set up my office hours yet, but I will do so probably today. And that will be under the My Office Hours link. And you can call me on this cell phone number during those office hours. And if I don't answer, just leave a message. I'll call back within 60 minutes. You can also try calling me outside of office hours if you'd like. I may be able to answer your questions. I may not, and we'll see how that goes. But it's always worth a shot. You can also text me at that number too, I think. All right, let's see. So attendance, you actually don't have to attend class if you don't want to, but people who attend class tend to do better than people who don't. And I do have a requirement here, as I said earlier, that I want people to be enabling their video for their Zoom while they're in the Zoom session. If you can't do so, then send me an email and with a reason for why you can't do it, and hopefully it's a temporary reason. My room is dirty is not a good enough reason. You'll just have to clean it up. All right, so let's see what's going on here with each of these tests. So you'll notice everything's set up in folders, and you'll see that each of these tests here, there's an ungraded copy, and then there's the real test that you'll be taking, which you'll be taking under honor lock. And honor lock's sort of changed a little bit. It's enabled me to allow the use of a handheld calculator, so you won't have to use the honor lock calculator, because I've been able to enable that in the conditions. I don't know if I've changed that in the syllabus yet, but you'll be allowed to use a handheld calculator, but obviously not a cell phone. Right? It has to be a handheld calculator. So the real test that you'll be taking is exactly the same as the ungraded copy, but you can take as many times as you like. I'll say that again. The real test you're taking is exactly the same as the ungraded copy that you can take as many times as you like.
Is that the extra credit quiz that we take the day before the test?
No, there's a number of those. And those are, now you'll notice also that these are videos for each of the ungraded copy questions. There you go, to practice test 1 videos. That's all of them there. Okay, so there's videos for each of those. And these are the mini lectures. These are all the topics we'll be covering in class. But in each of the folders that are below that, you'll see that there are extra credit quizzes. And the way you'll access those is you'll do the practice quiz. You need to get 80%, and then the credit quiz opens. So let me show you what this looks like from a student point of view. And what you'll see in each of those folders, for example, significant figures folder, you've got the qualifying quiz, and then you've got here in the reaction orders folder, you've got the practice quiz. That's all you'll see until you get 80%, and then the credit quiz appears, and you get 2 attempts at that. You can have as many attempts as you want at the practice quiz, and you just have to get 80% to make the credit quiz open. The other thing is that you can see what you've done, what you haven't done, by going to your grades report. And you can see all of this here in the extra credit test 1 is right here. So if you've got a 0 for something, chances are you haven't done it yet. And that would be a signal for you to go do it. Now, these are all due the day before the test is due. I'll say that again. All the extra credit is due the day before the test is due. But the extra credit is extra credit. You don't have to do it, although you'd be pretty crazy not to. The other thing is that I wanted to make these worth half a point each, but I can't do that in my courses. So what I do is these are all added together, and whatever this is divided by 2, that's going to be your score for your extra credit, and that gets added to your test grade. Is everybody clear on that? Does anybody have any questions? Okay, so let's go back to the syllabus here. You can see what I'm talking about. So the extra credit is here. It says that it should be something about half the aggregate there. And it's due the day before the test is due. So let's go take a look at the schedule here. And you can see your first test is due on February 4th. So all of the extra credit would be due on February 3rd. And as far as the test goes, you can take that anytime you like up to that date. You don't have to wait. And so I'm talking about this test 1 here. You can take it at anytime you like up to that date. My recommendation would be to take it well before the due date. That way you won't run into any emergencies where you won't be able to take the test or anything like that. And the way you'll study for it, you'll just take this ungraded copy as many times as you need to until you're getting a good score on it. Make sure you do it closed book. Practice everything you need to practice, and you should be okay. There's really no reason anybody should fail this course at all. I don't know. Think about the courses you've done in the past. How many courses have you taken where the test you're taking is actually a test that you've been able to take multiple times over and over again, as often as you want to? I don't see how you can really fail. The only way you can fail is if you don't do it, if you don't do the work. The work's not that hard. The material's not that hard. It's just a question of you putting in the hard yakka, as we say in Australia, putting in the hard work. Does anybody have any questions so far?
Yeah, I have a question.
Yeah, David.
So last time I took this course, you said that the quizzes were extra credit, but when I ended up grading all of my quizzes, my tests, it ended up massively lowering my test grade. At least it looked like in the grading book.
Well, the extra credit lowered your test grade? No.
Or maybe it was the homework. Is there still homework?
Oh no, no. You're talking about for Chem 2045. There was homework attached to 2 of the tests, the first 2.
That's what it was. Yeah.
Yeah, but
Okay.
in this course, there isn't any homework per se. That's part of that. Except to say, well, that's actually not entirely true. Well, it's not really I suppose you could call it homework, but it's not. It's different to what it was in Chem 2045. So for tests 3 and 4, let's go down to the bottom here. Here we go. So your test 1 grade is test 1 plus any test 1 extra credit. Test 2 is test 2 plus any extra credit. Now test 3, there's going to be 70%, and then there's some essays you'll have to do as well, and then a units quiz, and there's also going to be extra credit as well. And for test 4, it's the same situation. Now these essays, the conditions are stated in the test 3 and test 4 folder. You can take a look at them if you like. They're not incredibly difficult, but they will require some modicum of time for you to put in. Most people do pretty well with the essays.
Okay. I just wanted to clear that up.
Okay, that's all right. All right, any other questions so far? Okay, so I think most of you have had some experience with Monologue up to this point. The test you'll be taking a closed book, but you will be allowed to use a piece of scrap paper. You'll be able to write on scrap paper, but you'll have to show that scratch paper in the room scan. And obviously, if I catch anybody cheating, it'll be pretty swift. There'll be pretty swift action taken, and I don't mince words. You're under. It's a condition of trust here, and if you break that trust, there will be consequences. It's as simple as that. And I'm not going to tolerate any cheating. There will be no second chances. Let me put it that way. Any cheating I find will be recorded. It'll be easy. There will be no doubt in anybody's mind exactly what's going on. And I will take every possible consequential action I can under the conditions at the college to make sure that it gets taken care of. All right. Let's see, what else have we got here? Now I've got here, let's see, did you have to use the calculator in unlock? That's actually not true now. I'm actually going to take that out of the syllabus. You may use that one, or you may use you can use the unlock calculator if you like, but you can also use a handheld calculator if you want to as well. So we'll fix that in the syllabus. So if you look at what I've got here, students are often inclined to leave work until the day it's due, and I don't think that's going to change this semester, unless you're a completely different group of students from the ones I've been teaching for the last 23 years. And it's unfortunate, I say it every time. People need to work ahead, but no, most of the time people just leave it till the day it's due. And the other thing I'm finding is that people leave studying for the tests until the day it's due. And, these are the students who usually have some sort of emergency on that day as well and are asking for extensions. And I'm not really inclined to grant them. I certainly will never grant an extension. I'll never grant an extension after the fact. People just seem to think it's some sort of afterthought. I don't know. Anyways, get your stuff done early, and you can avoid the issues. I've got to change that here. All right. Does anybody have any questions? So this is the schedule, obviously, for spring. I forgot to change that. And I'll cross that out as well while I'm here. All right. So does anybody have any questions so far?
Dr. Musgrave?
Yeah, Lonnie.
I just have one quick question. I know you were talking about the use of the calculators. Are there specific calculators that we're allowed to use, or no?
Well, you can use graphing calculators if you like, but you can't use, I don't want people using cell phones. I don't want people using like supercomputer type calculators. I think you know what I'm talking about. Be reasonable when you're choosing a calculator. Graphing or scientific is going to be fine. Is that okay, Lonnie?
Thank you.
Okay.
Yes, sir. Thank you.
Any other questions so far?
I have another question.
Yeah, Alexandra?
So with how the practice tests, you said they're the same as the actual tests.
Yes, that's right.
If it is like a math problem, are they going to be the same exact numbers, or are the numbers going to be different?
No, the numbers will be different.
Okay.
So if it's compounds, chances are those will be different as well. But the questions are exactly the same. And you see these videos here. These go through all the different kinds of questions, right, that you'll see on the test. It's pretty transparent. The thing is, if you can get 90% on the ungraded copy, close the book, then there's no reason you should be failing the real test when you take it. I've had people take this test, 30 times, and that's fine. I've also had people not take it at all, which I think is a poor choice, but they don't usually do very well on the real test when they take it, if they don't try the ungraded copy a few times. We take a look at the ungraded copy here for test 1. The real test is just going to be the same thing. So these numbers here, for example, will change, Alexandra, in the real test, but the question is going to be the same. Find the order with respect to A, just the numbers will be different. Is that clear?
Yeah, thank you.
Okay. Anybody else have any questions about this? Anybody have any other questions about this? Okay. All right. Looks like I'll have to submit this to get out of it. All right, so I'll just continue on to syllabus here. So at the end of the course, well, I suppose at the end of test 4, you can see what the story is here. There are 2 ways to get an A in this class. You can get more than 90% on all 4 tests. And that will allow you to exempt the final with a grade of A. And if you were to not get 90% on all 4 tests, then you could take the final and still get an A by taking the average of all 5 tests. Additionally, the final replaces 1 lower test grade as well. If you have more than 80% on all 4 tests, you can have a B in the class without taking the final. But again, you can take the final to try and get an A in the class. If you do have a B, then you can't lose that B. No matter how badly you do on the final, you'll still have a B in the class. Does anybody have any questions? So let me reiterate here. It's not the average of 4 tests. It's going to be, you need to have more than 90% on all 4 tests. My philosophy here is that if you are going to exempt the final, then you had better have gotten an A on everything, not just an average of A on everything. Does anybody have any questions?
Dr. Musgrave.
Yeah.
One more question.
Mm-hmm.
Do you offer any credit for tutoring sessions?
No, I don't offer credit for tutoring sessions, no. But that being said, you can get help from me, or you can get help from the tutors, SPC tutors and other tutors on tutor.com remotely, or either way. But that's up to you, and whenever you need that help. No, but I don't offer any credit for actually doing tutoring.
I have one question.
Yeah, Marta.
I'm sorry, I just missed a couple of first minutes of this class. So I was in your class last semester, and I was able to watch some of the Zoom sessions when they were recorded. I work a lot, and I'm not always able to be online. So I'm sorry, I just don't know if all the Zoom sessions are mandatory, or we can just watch the recording.
No, you can watch the recordings. It's fine.
Okay. I'm just afraid I won't be able to do Thursdays, but
Yeah, it's all right. It's all right.
Okay, thank you.
Now, what I was finding last semester, there were actually times when maybe 2 people attended the Zoom sessions. 2 people. I'm not kidding. 2 people might turn up to the Zoom sessions. And I know that the rest of the people who weren't there had very good intentions of watching it, but I know that most people didn't. So look, it's up to you. I'm not here to force you to pay attention or whatever, but you know, in the end, it's up to you how much time you want to put in. And the thing is, if you fail this course, it's not my fault. I'll take no responsibility at all. I've set it up so it's completely transparent. You put the time in, you'll pass. If you wait till the last minute to do everything, you'll fail. It really is that simple. So, you know, keep up with the work, come to the Zoom sessions. If you can't be at the Zoom sessions, watch them. If you have questions, call me or email me. If you need help, go to tutor.com, get help from the SPC tutors or any other tutors that are on tutor.com. Or if you need, either way, me or tutor.com, whatever makes you most comfortable. Does anybody have any questions? Does anybody have any questions?
On the syllabus, it says that the test allows 2 attempts. Is that with a penalty if you take it a second time?
No, there's no penalty.
Okay.
But it does take the whatever grade is highest out of the 2 attempts. I know I've always struggled with whether I should allow 2 attempts or not, since it is the same as the ungraded copy, but you know, that's how it is. I mean, some people, that's all they do is they just take the 2 attempts. They don't even take the ungraded copy at all, which I think is a bit nuts, but that's, those people don't tend to do that well either. No, look, this is down to you and how much time you're willing to put in. So my recommendation would be during the course of the semester, do the extra credit as you go, as we go through each of the topics, do the extra credit as we do them. And that way you won't have to make the choice of whether to study or whether to do the extra credit. All right, does anybody have any other questions? Anything at all about the course that might not have covered? So there's no textbook, but if you want to use one, I can recommend the Trode textbook here. But you'll notice I've got here any edition, and you can get the early editions of this real cheap. I mean, the latest one obviously is going to be really expensive. It's going to probably be $200, $300 or something ridiculous like that. But the earlier editions, which aren't real different, by the way, from the current edition, you can get them pretty cheaply from other places. There's this really long river in South America. Think about that. That might give you a clue as to where you might be able to get earlier editions of this book, but I can't say what that place is.
I have a question.
Yes, David.
So for test 1, in the last course, I remember for the first few quizzes, the way we learned how to do the quizzes was we went to like the separate website, and it showed us like step by step each different type of equation that we would do for that quiz. And
really?
then,
No,
and then
no,
in the latter half,
no, I'm not really.
I'm really not this time around.
I'm really not understanding. Oh, yeah, okay. You're talking about like the soft chalks?
Yeah, that's what I was talking about.
Okay, yeah. Well, this time it's all PowerPoint.
All PowerPoint.
Yeah,
Okay.
yeah, just like it was for test 3 and 4.
Okay.
Yeah. All right. Any other questions? All right. So there's still some people here who don't have their video enabled. The expectation is that you will have your video enabled, and you know who you are. And if you don't have your video enabled, but in the future, for future classes, I definitely want to see that. And if you can't have your video enabled, then I'm expecting that you'll send me an email telling me why you don't have your video enabled. And it better be a good temporary reason for not having it enabled. Okay, thank you. All right, any other questions about the course, grading, what you'll be expected to do? All right, let's talk about the kinds of resources. And yes, just as I was alluding now, you've got the PowerPoints here. There's also printable versions of those that you are more than welcome to print out. They're bled black and white. If you try and print out the PowerPoint, you'll run out of blue ink pretty quick. But this is a printable version, so you're more than welcome to print that out if you want to. You don't have to. Along with that, there's also these videos, these mini lectures here, which pretty much go through the same stuff as I go through in the PowerPoint. So that's just another resource for you. Most people tend to like those as well. Then you've got these extra credit quizzes and sometimes extra problems and things in these folders that you can do. And I'll alert you to those as we see them. All right. Okay, any other questions or anything about the course? So let me just say one other thing here, and that is that, this is not a course to be scared of. The material is not that hard. The material in the course is not that hard. Every person who's enrolled in this course is more than capable of passing it. The only reason people do not pass this course is because they don't put in the time. They leave everything to the last minute. They don't do the extra credit. They don't do what's required, and they end up failing. But it's all their fault because they haven't put the time in. At SPC, if you're taking a 3-hour course, a 3 ECH course, in the student responsibility section, it says that you should be doing 6 hours per week of revision and activities outside of lecture. I mean, that's outside of what we're doing right now. That's what you should be doing. That's what's expected for a 3 ECH course. I think a lot of students have the expectation they should just be able to study for 2 hours and get an A in the course. Study for 2 hours for each test and be done with it. No, it doesn't work like that. You'll have to learn the material. You'll have to do the work. If you don't do it, you'll fail. Make a decision. Are you going to put the time in or not? It's up to you. All right, does anybody have any other questions? Anything else about the course you want to ask? Any other question? Okay, well, we'll get a start then. It's a bit slow. I don't know why it's taking so long to open this. You know what? I probably shouldn't be doing that anyway. Probably should be doing it from here. Okay, let's do it from here instead. Okay, so we're going to start out here on reaction orders and rate equations. You'll find that this will align with what you're doing in the lab as well. And one of the first labs we do has to do with reaction orders and rate equations. So we're starting out here, we've got a reaction, and you'll see it has a certain stoichiometry associated with it. We've got a 2 here in front of the HgCl2 and a 1 here in front of C2O42 minus. You'll notice that the rate equation is this: rate equals K, HgCl2 to the power of 1, and C2O42 minus to the power of 2. Now these powers here are called reaction orders, and we find these out by experiment. We don't look at the coefficients in order to determine these specific reaction orders. Now these reaction orders will enable us to determine how quickly or how fast a reaction goes. So rate is another word for speed. So if you were just measuring your speed, like when you're driving, it would be the change in distance over the change in time. A reaction rate is the change in the concentration of reactants over the change in time. So it's really no different. So the more quickly the reactants are being used, the faster the reaction's going. It's really that simple. So as I've said here, the rate equation for this reaction was found by experiments and was determined to be this with these reactants here to these specific powers 1 and 2. The other thing we see in the rate equation is something called the rate constant, and that is a constant value unique to each reaction at a given temperature. So that's going to be a constant value. So the orders, as I said, reaction orders are the powers here. So let's get a bit of context as to what those orders actually are telling us. So let's say we've got our rate equation here, K, HgCl2, and then C2O42 minus to the power of 2. And we start off with concentrations of each reactant as being 1 molar. Now what we know is as the reaction proceeds, the reactants will turn into products. So what we're expecting is that these will eventually go down to nothing, or we'll just say they'll go down. They might not go down to nothing, but they'll go down is what's going to happen. And there's going to be a rate associated with that. And what we can do is we can plug in those concentrations and get an idea of what the rate looks like. So if we start off with 1 molar concentrations of those 2 reactants, then the rate will simply be K, because we're just putting in 1 for each of those concentration values there. Now, if I double the first one, the HgCl2, and leave the second one the same, then what's going to happen is the rate would be 2K. So what we're seeing here is if we double the HgCl2, then the rate doubles as well. This goes from K up to 2K. But if you doubled the C2O42 minus and left the HgCl2 the same, you'll see that it would be 2 squared here. That's where that squared comes into play, and you'll see it's 4K. So what I'm saying is that the reaction will go faster if you double the C2O42 minus than you would if you doubled the HgCl2. And it's all got to do with these reaction orders, these powers here. The bigger the power is, the more effect changing that specific reactant will have on the rate of reaction. And that's all I really want you to get at this point. It's just that reaction order has a big effect on the rate. Does anybody have any questions so far?
Is the second one always doubled, or is it just because of the 2 exponent at the bottom of the rate?
It's really just a 2 exponent, but I'm just looking looking to give you the effect of doubling the first one and leaving the second one the same, and then leaving the first one the same and doubling the second one. So I'm just trying to show you the effect of that power, that exponent, and how it changes the rate. Is that okay?
Yeah.
Okay, thank you.
Mhm.
So changing the C2O42 minus, the second one has a bigger effect on the rate. And, you know, chemists are always looking for ways to increase reaction rates. So that's what we're getting from that. So I had said initially that the rate equation that we get, this rate equation here, we got from doing experiments. So what kind of experiments are we talking about? So for this one, there were 4 experiments that were run, and they each started with these initial amounts or initial concentrations of these 2 reactants. And when we look at that, you can see that there's a certain rate that we get with each of these reaction conditions, these starting concentrations. So let's talk about what that initial rate is. So then this reaction, let's see, I need to pull up my thing here. You've got this reaction here. It goes C4H9Cl, and it goes to products. That's the reaction we're looking at. So it's only got one reactant. And as you can see, it starts out as 0.1 molar, and then over time, the reactant concentration goes down. Now, why is it going down? Well, it's because the reactant is turning into products. It's really that simple. So you can see that line going down there. Now, the rate is going to be C4H9Cl concentration divided by the time. So that's going to be the slope of that line. That's going to show you the rate. Now, the initial rate is going to be the slope of the line at that point, at the initial point of the reaction. So the slope is actually the rate. If you think of what the slope is, remember what slope is. Slope equals change in y over change in x. So what is y here? Well, it's the C4H9Cl concentration. And what is x? It's time. So it is really the rate. Does anybody have any questions so far? So that's something you're given. You don't have to figure out the rate. I'm just showing you where it's coming from. But you've got the concentrations here, the initial concentrations, and then you've got the rates. So if you look at it, you can see, you can get an idea of what's happening here. So you've got 0.105 and 0.150 for the first experiment, and you get this rate, 1.80 times 10 to the negative 5, and it's measured in molar per minute. So it's the concentration divided by the time. But look what we did for the second experiment. We left the HgCl2 the same, and look what we did. We doubled the C2O42 minus. See, it was 0.15, now it's 0.3. Look at the effect it had on the rate. So you got 1.8, it goes up to 7.2. That's 4 times. So you can see that doubling the C2O42 minus quadrupled the rate. 7.2 is 4 times 1.8. That's how I know. Now, if you look at the reactions 2 and 3, you see the concentrations of C2O42 minus are the same. And you'll notice that for reaction 3, it's 0.0520. For reaction 2, it's 0.105. That's about double. So reaction 2 is about double reaction 3 for the first reactant. And you'll notice again, we see this doubling of the initial rate. So that's what we're doing, is we're comparing these reactions in order to figure out what the order of the reaction is. So let's see how we do that math. So this is the kind of question that one of the questions you'll have to do on the test will be, you'll be given this kind of experimental data, and you'll be asked from the rate equation to be able to figure out the values of m, n, which are the powers here, and k, which is the rate constant. We can do all that given the data that we have here. So you always need the initial concentrations of your reactants, and then you'll need a bunch of initial rates as well. So let's say we want to find m. Now m, if you'll notice here, look at where m is. M is the power for HgCl2. Right, that's what I want you to be clear about. M is the power for HgCl2. If I want to find m, what I'm going to have to do is find two reactions where n is the same, so it ends up cancelling, and m is different. So the reactions we would use would be, in this case, would be 2 and 3. So if you look here, you can use 2 and 3, 0.300 and 0.300, and 0.105 and 0.0520. So those are different, but these guys are the same. Can anybody see any other reactions I could have used in order to find m? I know I've got 2 and 3.
1 and 2.
1 and
3,
2.
4.
No, I wouldn't use 1 and 2.
1 and 4.
1 and 4 would be fine.
1 and 4.
Oh,
Yeah.
can we not cancel out the first column?
No, David, because you want to find m, so those two values have to be different.
Oh, okay. Okay.
But the values for n have to be the same. That's why I chose these two, 2 and 3, so that these will end up cancelling. So look what we do in the next step. So what we do is we compare rate 2 and rate 3. So rate 2 goes on top, rate 3 goes on the bottom. And then we've got Ks. The Ks end up cancelling. And you'll also notice that because these values are the same, those will end up cancelling as well. So we take the rates, we plug them in. We've got 7.20 times 10 to the negative 5 over 3.60 times 10 to the negative 5. And then everything cancels here. And we end up getting this kind of statement where it's 2.00 equals 2.02 to the m. So the 2.00 comes from 7.20 times 10 to the negative 5 divided by 3.60 times 10 to the negative 5. So that's 2.00. And 0.105 divided by 0.0520 is 2.02. And that's to the power of m. All right, so let me explain to you how we're getting that value of m. So often in these kinds of situations, we're actually solving for a power. Now we can eyeball it because we're just looking for the nearest whole number. And it's pretty clear that m would have to be 1. But what if it wasn't so clear? Well, what we can do, if we've got any situation where we've got x equals y to the z and we're trying to solve for z, then z can be solved by doing log x divided by log y. Now I can do a little bit of math here to show you this, but so if you do some log x equals log y to the power of z. So by doing some funky log math, log x equals z log y. And then you can see that z would be equal to log x over log y. So that's another way you could do this. You could do m here would equal log, you can do this in your calculator too, log 2.00 divided by log of 2.02. So that's how you can solve for it. So if I gave you this, say 27 equals 3 to the m, can anybody tell me what m is?
3.
3. Now think of what 3 to the m means. It means 3 to the 3, which equals 3 times 3 times 3. And if you were to do this, you could do m equals log 27, do this in your calculator, log 27 divided by log of 3, and it will come out to be 3, quite magically. All right. What if I did this? 16 equals 2 to the n. What does n equal? I'll give you a hint, it's not 8.
4.
It's 4.
4.
Does anybody have any questions about doing this? About solving for a power? Okay, I'll say one other thing too about this. You'll notice I did rate 2 divided by rate 3. I could have done rate 3 divided by rate 2, but if I did that, I'd end up with fractions here. It would be 1/2 equals 1/2 to the power of m, which I think is going to be a little bit more difficult to solve. So my tip for you here is, if you've got a choice between which rate to put over which rate, always put the bigger one on top so that you end up with whole numbers when you're doing the math. So let me show you, it's rate 2 over rate 3. So let's say I wanted to find the value of n. That means I want the values of m to cancel. So I want 1 and 2 to cancel. I could do that there. So 1 and 2 I can do. What else could I do if I wanted to find the value of n, which is the rate with respect to C2042 minus? I can use 1 and 2. What else can I use?
3 and 4.
3 and 4 are okay as well. They're the same. See, they're okay. So I can use 1 and 2 and 3 and 4. But if I'm going to use 1 and 2, I would do 2 over 1 because 2 is bigger than 1. Here, rate 2 is bigger than rate 1. So I go with that. Okay, rate 2 over rate 1. So that's what I do. I do rate 2 on top, I do rate 1 on the bottom. And you can see that the rates divided by each other would be 4. And then the 0.300 divided by 0.150. So I'm just taking those directly from here. Would be 2.00 to be n. So n would equal 2. Does anybody have any questions about finding the reaction orders? Okay. Now the overall order is going to be just the sum of the reaction orders, so m plus n. So the overall order would be 1 plus 2 is 3, because m is 1, n is 2, 1 plus 2 is 3. Now, I also need to find k here, and to find
I
k...
have a question.
Sorry, go on. Yes, sorry, Alexander.
So for the when you find n, where it's this the 400, you just, how did you get that?
The 4.00?
Oh yeah. Was
Yeah.
it because you divided the 7.20 and the 1.80?
That's right. And the 10 to the negative 5s cancel. So if you put it in the calculator, it'll come out to be 4 or 4.00.
Okay, thank you.
Is that okay?
Yep.
All right. Any other questions? So I told you that k is the rate constant. That's this value here. And it's going to be a constant value. It doesn't matter what experiment you use here. I'm choosing to use experiment 1. But these are the values that I can plug in here. And I've already got M and N, so now I can solve for K. So this is how I'm solving for K. So rate 1 is 1.80 times 10 to the negative 5 molar per minute equals K times 0.105 molar to the 1 times 0.150 molar to the 2. So let's look at where I'm getting those values from. These are the concentration values. They come directly out of a table. The initial rate is the rate. And then we've already got the orders here, which we just calculated, M equals 1 and N equals 2. So if we plug in everything, that's what we get. And you can see the K value would be 7.62 times 10 to the negative 3. Now, I also want to show you how I get that unit as well, because that's important too. So first of all, let me show you numerically how we get that value. So K would equal 1.80 times 10 to the negative 5 and the unit there is molar per minute. And that's over 0.1505 molar times 0.150 molar squared. So if you do the math here, you'll end up getting the 7.62 times 10 to the negative 3. Is everybody okay with how I'm getting the 7.62 times 10 to the negative 3 value? Does anybody have any questions about that? Does anybody have any questions about where any of these numbers are coming from?
Do you mind just working out that problem?
What do you mean?
Like,
I'm sorry, Alexandra.
So would you just like multiply the 0.105 times the 0.150 squared,
Mm-hmm.
and
That's
then
right.
you would divide it?
Divide that into 1.80 times 10 to the negative 5, yeah.
Oh.
But in your calculator, this is probably what I would do. I do 1.80 e negative 5, so you use the exponent here, divided by 0.105, then divided by 0.150 squared, or 1.80, this is just in your calculator I'm talking about, Alexandra, divided by 0.105, divided by 0.150, divided by 0.150. And that will work too. Now the logic here is you multiply everything that's on top and you divide everything that's on the bottom. So you can get away with that.
Thank you.
Is that okay?
Yeah, that makes sense. Thank you.
Yeah. So that'll work every time. You know, if it was to the power of 3, then you just do this 3 times. And it should give you the right answer. All right, does anybody have any other questions? All right, let's talk about the units then. So you'll notice that the units, going back up here, we've got molar units on these guys, and we've got molar per minute on the initial rate. So the way the units work out, you've got molar per minute over m times m squared. So I'm just looking at the units now. Now, a couple of rules that you should be familiar with here as regards powers. So you know this, that a to the x times a to the y equals a to the x plus y. You also know that a to the x over a to the y equals a to the x minus y. Is anybody unfamiliar with those kinds of rules? I know you did them in pre-algebra or college algebra or something, right? I hope. Anyways, if you do that, then what happens is you'll get molar per minute on top. And we'll have molar cubed on the bottom. And that's molar to the 1. So that would be molar to the -2 and minutes to the -1. And that would be where I get the unit from down here for K. So the -2 is 1 minus 3. That's where that comes into play. Does anybody have any questions? Does anybody have any questions? Now, the unit of K is not always going to be what I have here. It's always going to depend upon whatever reaction orders you come up with here. So it's going to vary depending upon what M and N are. So just be aware of that. It's not always going to be the same thing. Does anybody have any questions?
I'm going back a little bit. When we're finding M and N, like for all out there, the 4.0 is equal to 2.0. Which one is on the top and bottom for the log formula?
I'll go back up over here. It's always this. If x equals y to the z, and you're looking for z, right? Z is always going to equal log of x divided by log of y.
Thank you.
Is that all right?
Yes, thank you.
Okay. Any other questions? You often won't have to do that, by the way. It always comes out to be pretty close to a whole number. All right. Let's take a look at the questions on the test and how those look. So you'll notice when you go into a test that there's always, here it says question 1, reaction orders, M and K overall order. So it'd be questions 1, 2, 3, and 4 are the important ones for that. And then, you got on to move on to question 2. So you can see what's relevant to what pretty easily. So when you're doing something like question 1, and it's the reaction order with respect to A, can anybody tell me which reactions you'd want to use in order to find the reaction order with respect to A?
2.
Which ones would you use?
1 and
1
3.
and 2.
You could use 1 and 2.
Yeah.
What else could you use? That's a trick question. That's a trick question.
It doesn't look like there's anything else.
There's nothing else you can use. You can only do 1 and 2 because you have to find 2 reactions where B is the same. So B has to be the same, A has to be different. So when you're doing it, you'll do, and remember how I said also make sure that you put the bigger one on top. So I would do rate 2 over rate 1 equals K, and it's going to be A to be M, B to be N, and that's going to be 2 and 2 there, and then K, A to the M, B to the N, and that's going to be 1 and 1. Now those 1s are for the experiments here. So rate 2 is 834, and that's molar per hour, over 161 molar per hour. You'll notice that the Ks will end up cancelling. They're the same. And then we'll have 0.626 on top. And that's to the power of, it's molar to the power of m. And then you'll have 0.248. And that's to the power of m as well. And see if I can enlarge this a little bit. Do that. And you'll see that the 0.264s to be n will end up cancelling. That's why we chose two of those being the same. So they end up cancelling so we can find our m value. So when you do the math on that, here's what we end up with. 834 divided by 161. So that's 5.18. And that equals, let's see, I get 2.52. That's to the power of m. So if you want to find m, it's going to be the log of 5.18 over the log of 2.52. And I get 1.73 for that. But you always want, whoops, 1.73, and you want to round it up to a whole number, so it'll be 2, and that would be your answer. When I was saying they always come out to whole numbers, I wasn't talking about these kinds of problems on the test. I was more talking about the ones on the pen and paper tests and on the extra credit. On the extra credit, you'll see them pretty much come out to whole numbers. These, you're going to have to do the log thing in order to figure that out. Now, you might be wondering, well, how would you know how to do that? Well, look, I've got videos for each of these kinds of problems down below the test. So you can look at those videos and it goes through and shows you pretty much exactly what I just showed you here. Does anybody have any questions about that question 1? Sorry, I didn't mean to do that.
why did you round it up to 2?
Because
Again.
these orders need to be whole numbers.
Okay.
So whatever it happens to be. Sorry, I didn't mean to do this. I don't know what happened. I accidentally hit that. Let's see if I can get rid of it. I'll force quit it. Anybody have any questions? Any other questions about this? So in question 2, it's asking for the order with respect to B. Which reactions would you use for that one? If you
1 and
wanted,
3.
yeah, I'd use 1 and 3 because you can see that that's how you can get the M's to cancel. Now, would you do 3 over 1 or 1 over 3?
3 over 1.
Yeah, so 540 is bigger than 125, so that's how I do it. So it's pretty much the same thing as what we just did, except now you're doing 1 and 3 here. Any questions about number 2? I'm not going to do that one again. Okay. So in questions 3 and 4, you're looking for K. One question deals with the numeric value and the other question deals with the unit. So let's look at the numeric value first. So you got your rate equation here, and you can see it goes rate equals, and then we're looking for K. Now we do have the A value, which is 0.247 molar, but we're not interested in the units here, so I'm not going to worry about that. And that's to the power of 3 times 0.257. Actually, I'll just do it properly here. I'll go rate equals K, A to the 3, B to the 3. And that's because we're told that information. Then we can substitute everything in. It'd be 103 equals 0.24, sorry, K, 0.247 to the 3 times 0.257 to the 3. And then you can solve for K that way. Is everybody okay with that? Getting the numeric value for that, for K? Anybody having trouble seeing where I'm getting any of those numbers from? Okay. Now in this last one, we're looking for the unit. And we're told here that rate equals Ka, M to A to be M, B to be N, and M is 1 and N is 4.
I have a
Yeah.
question. So for number 3, after
Yeah.
you get 103 equals K, after you get that equation, do you just divide the whole equation by 103?
No. Let's go back. Let's see if I can get this. Oops, sorry. It'd be 103 divided by 0.247 cubed times 0.257 cubed.
Okay.
Or 103 divided by 0.24, menu calculated 0.247 to the power of 3 divided by 0.257 to the power of 3. And that might be in parentheses.
Okay, that makes sense. Thank you.
Is that okay? Are you sure?
Yeah. Yep. Yeah.
Okay. Okay, so for the unit here, we're told that the initial rate unit is molar per hour. So let's go back to here. So rate equals K A to the 1, B to the 4. Okay. So the rate is molar per hour. And we've got K. We got the unit for A will be M and the unit for B will be M to the 4. So K equals molar per hour divided by M times M to the 4th, which is molar per hour over M to the 5th. So the unit would be M to the negative 4, H to the negative 1. So the unit there, so the unit of K is found to be M to the X, H to the negative 1. So the value of X would be negative 4. And that's how you figure that out. Does anybody have any, sorry, go on.
How did you get the negative 4?
It's going to be 1, so that's M to the 1 minus 5. 1 minus 5 is negative 4.
Okay.
That goes back to those power rules I was talking about earlier. Does anybody have any other questions? Okay, well that's it for today then. So I will see you hopefully on Thursday. I might see some of you soon though for lab, but other than that, I'll see you on Thursday.
Thank
All
you.
right. Have a good day. I'll see you all later.
Thank you.
No worries. Bye-bye.
See you.
Bye.
Have a good day.
You too.
I have another question.
Yeah.
Is H always -1?
Well, it'll be whatever it will be, but it'll be per, if usually will be per hour. If it's
Okay.
per, then it will be to a -1.
Okay.
Generally, it will be like that, yeah.
Okay. Awesome. Thank you.
All right. Any other questions?
No.
All right. Let's see who else is here. So Lonnie, Emmeline, Alexi, any questions?
No, sir.
Okay, thank you.
No.
Alexi, are you on?
Yeah, I'm here. Sorry, I was just finishing up my notes.
Okay. Did you have any questions?
No, I'm all good. Thank you, though.
Okay, no worries.